All right, good evening. Tonight we are going to start part two of the Conservation of Mass Notes, and this one is going to focus on the I CAN statements of stating the general properties of metals, nonmetals, and metalloids, as well as explaining where and how elements are grouped on the periodic table. First of all, a little bit more detail about the organization of the periodic table, focusing on that second I CAN statement first. It's similar to a calendar. It has horizontal rows and vertical columns, and each one represents an important set of information for the elements in those groupings. Mendeleev was the first one who discovered the set of patterns and actually grouped them. So he created the first periodic table, which looks similar to the one that I put on the top right hand of the presentation. But when he designed the first periodic table, he organized it by the atomic mass. And now, as you know, it is not by the atomic mass, but it is by the atomic number. So the elements go in order with the atomic number. Now, most of the elements still fall in order of the atomic mass, but there are some that do not. And he was able to predict some of the elements that had not been found at the point that he constructed the first periodic table by using the properties of the ones that had been found to predict them. And so he could tell that a missing element was very reactive based on the ones around it being very reactive, or it was a gas in its natural form because of the other elements listed close to it on the periodic table. You will also be able to kind of predict about elements that are around other elements based on their physical properties. So, breaking the different parts of the periodic table down, there are periods, which are the rows going across the periodic table. And then there are groups, which are also called families, that go down the periodic table. So if you notice, there's 7 main periods, and there are 18 groups. All right, so in front of you, you not only have your notes, but you have a periodic table. I would like you very, very carefully to draw a zigzag line like the one that you see here on your periodic table. If you need to pause that, go ahead and pause the presentation to do that. Go ahead, and at any other time in the future when we do some adding on to the periodic table, because we are going to be customizing this table so that you can understand it a little bit better and use it to study. So, what is the zigzag line for? There are 3 main types of elements on the periodic table. There are metals, nonmetals, and metalloids. Metalloids, except for one that's touching it, all touch the zigzag line. So boron, silicon, and this one, and this one, and this one, and this one, and this one are all metalloids. However, aluminum is a metal. This line that separates metals from nonmetals, we just call it the zigzag line. There's no special name for it necessarily. Know that metals fall to the left of the zigzag line, and nonmetals are to the right of the zigzag line. So what I would like you to do right now is to color code these. Make a key somewhere in the top, middle to left side of your periodic table called metals, and I would like you to make the metals blue. So you're going to go ahead and color code all the metals blue. Notice that there is one missing element here. Do not color that one in. That missing element on this chart is actually over here, and that is not a metal. So do not color hydrogen blue. But all of these other ones, up until you get to the metalloids, including aluminum, go ahead and color blue. Now, the ones that fall on the zigzag line that are metalloids, I would like you to color yellow. And lastly, I would like you to color all the non-metals, all the ones located to the right of the zigzag line. Great. Remember to pause this if you need more time. All right, so let's talk about properties of the different elements listed on the periodic table, because again, the properties are what helped Mendeleev figure out that we have some missing elements. We've not found all of them yet, and that he could almost predict what those properties are based on the elements that were close to it. So understanding properties is an important part of understanding the periodic table. Properties, the main purpose of them is to help identify and classify substances. Physical properties are characteristics of a substance that can be observed without changing it into a different substance. So no matter which one of these you might be testing, it's not necessarily changing the substance into a different substance. Examples of these are freezing point, meaning the temperature that something freezes, density, which you should have some knowledge on from 6th grade, hardness, texture, color, solubility. Solubility is the ability to dissolve, and we'll talk about that later. States of matter at room temperature, and chemical properties are properties that describe a substance's ability to change into a different substance. So it has to do with how reactive it is as well, the ease and the speed that it combines with other substances to form a new substance, how reactive it is. So if it's not reactive at all, then its ability to change chemically is less, and then vice versa. So reactivity on the periodic table is always more on the left side of that group of elements and less as you go over to the right side of that group of elements. Let's take oxygen. Oxygen is pretty reactive, and it is a non-metal, gaseous non-metal. And then let's take iron and gold and look at those for a second. If you look at iron and gold on the periodic table, and by the way, I'm going to flip back so you can see it on the screen, but iron is located right here, and gold is located somewhere down at the bottom. Here it is, gold. Okay, so as you can tell, iron is located a little bit further left than gold on the periodic table, so it is more reactive, and oxygen is reactive. So what happens is that iron and oxygen can combine together to form a new substance, rust. However, gold and oxygen do not combine to form a new element. So we mentioned that the state of matter in its natural form is a property of elements, but also how it can change between states of matter is also some of its property, its freezing point, melting point, and boiling point. So here, this screen, I love this diagram because it does incorporate thermal energy. So it is talking here, if you take the energy and decrease it, okay, which usually means that there's a drop in temperature, or if you take the energy of something and increase it, then this kind of shows you the scale. So something such as gold its thermal energy in its normal state of solid is lower. And we know that if we add heat to it, we're going to change it into liquid gold. Um, if we take water, which is two elements combined, hydrogen and oxygen, in its form at room temperature, it is liquid form. If we stick it in our freezer, then we can create ice cubes. So we are lowering the temperature and creating a solid out of it. Now what's really nice about this diagram too is it shows you, since we also just studied structures of atoms, it shows you the atom up here, and it kind of shows you how the atoms might look to the human eye, if you could see them, in the different states of matter. So when water is in its liquid state or liquid phase, then you have these atoms that have some space between them and they're moving more. Solids are packed more tightly and they are moving less, and so forth. Okay, moving on to specifically talking about properties that distinguish metals from metalloids from nonmetals. Physical properties of metals. They have luster, which means they are shiny and they reflect light. They also are solid at room temperature, except for one, and that is mercury. It's a silver metal that used to be placed into thermometers, and is still in some thermometers, but we just do not use them in education. Conductivity. Metals conduct or transfer, meaning pass on electricity and heat very well. They are also malleable, which means you can take a metal and hammer it down into thin sheets. Ductile, meaning that it can be stretched into wires. So, kind of makes sense. Our wires, a lot of them are made of copper and other metals. And then last on this list, but I'm sure there's more, is higher density. So metals have higher densities than non-metals usually. So chemical properties are that metals are reactive, especially the ones all the way on the left side of the periodic table. Now we're going to skip over to the right side and kind of forget those metalloids for a second. We'll come back to them. But the physical properties of nonmetals is that most of them actually are gas at room temperature or in their natural state. So if you think about it and you look at the periodic table, let's go back there quickly. These are the nonmetals over here, and if you look at it, you've got nitrogen, oxygen, argon, pretty sure that is a gas, and several other ones that are gaseous in their natural state. Sorry. And then they don't have luster, which means they are not shiny and they do not reflect light. They usually do not conduct electricity or heat very well. They are brittle, which means if you were to try to hammer them, if you could, and they're not a gas, then they would break easily instead of changing shape. And they usually have lower densities than metals. Chemical properties are, many are reactive, especially the ones closer on the left side of that group of elements. And so they combine well with other elements to make compounds. If you look at oxygen, for example, we just gave you an example of how oxygen can combine with iron to make rust. Also, we can combine oxygen with hydrogen and make water. Keep in mind that the farthest right group or family, which is group 18, family 18, are the noble gases, and they do not react with other elements. Back to the metalloids, the ones in the center, the dark blue right here. They have some characteristics of metals and some of nonmetals, and oftentimes that's why they are called transitional metals. They are solid at room temperature. Some of them are shiny and some of them are dull. Some conduct electricity well, some others don't, and some are ductile and malleable and